Okay, so today, 423.18, here's our we're going to be solving right triangles using right triangle trigonometry. I sincerely mean this, that sometimes the things that have the big words seem to be the easiest. Trig is actually pretty easy. And one of the things I like about trig, for me, is if I have a picture, if I see a picture, then I can usually do it, okay? So, first of all, example 1, I'll look through it, and I've got two choices, if you know an acute angle, or if you don't know an acute angle. So if I look at this one, I do not know an acute angle. Does that make sense? I don't have a value here. I don't have a numerical value here. I do not know the measure of that angle, and I do not know the measure of that angle. We don't count the 90. We don't count the 90 because you'd never find the height of anything if you're directly underneath it. And that makes sense, doesn't it? You'd never use a 90 because you could never find the height of anything if you're directly under it, okay? So what do we do? Well, we're going to choose an acute angle to solve for. So it does not matter to me. And Lynn, since you're raising both hands at the same time, which angle do you want? I or P? Which? Yeah, it doesn't matter to me.
I want I.
I it is. I'm going to circle it. Thank you. So step 1, choose an acute angle to solve. Thanks, Annalyn. Okay, what's my second step? Use the two given sides, right? So I'm going to use the 10 and the 7, right? Now, from the angle, you get your names from the angle. This is my hypotenuse, and that's my adjacent, okay? I don't know anything about the opposite, but I'll figure that out later using something else, okay? So again, from the angle, I know the adjacent, and I know the opposite. So I'm going to set it up, but I'm going to use the trig, okay? I would say that I'm going to use cosine. Cosine of angle I is equal to 7 over 10. Cosine because it's adjacent and hypotenuse. Now I used I instead of theta because theta just represents any angle, right? Theta, that symbol just means any angle. But the angle I want is I, okay? So now, what I have to do though is use the inverse, right? So instead of cosine of I, I'm going to go cosine inverse of 7 over 10, okay? And I can let my calculator do that for me, okay? So I've got cosine inverse. So let me see, my calculator, type that in. I'm going to go second cosine. You got to hit second cosine, right? 7 divided by 10, right? Cosine inverse, and I get an answer of about 45.6. Everybody try that. I want to make sure everybody pushes the buttons right, okay? Everybody try that. So I get about a 45.6. So angle I is equal to about a 45.6 degrees. If you don't get that answer, let me know.
I did not get that. I got the answer. Wait, so we go. Yeah, I did 2.8. Yeah,
okay, then check your mode. Real quickly, check your mode.
45.6.
Are you in radian or degree mode? This is a great question because there's two ways to measure angles. If you're in radians, so I went to mode. I went to my mode button, and if you're in radians, switch it to degrees, okay? Were you in radians?
Yeah.
You're in radians? Yeah. And now try it again. Try it again. And you should get about 45.57. Okay, if you don't get that, ask me again. I'll double check, okay? Natalie, did you get it?
I'm trying to go back to the screen.
Okay.
Clear? I'm at the Y's.
Oh, you want to put quit. Second quit. Second quit. Okay, Natalie, second quit. Got it?
Oh, I got you.
Okay, did you get that answer?
I did.
Good. Okay, now, we have angle I, which is, I'm going to write up here, 45.6. Okay, now, if we have to find the rest, angle P is pretty easy, right? Right, so find the other angle, 90 minus theta, right? So angle P is pretty easy because you know that these two have to add up to 90, right? So angle P would simply be 90 minus my 45.6. I'm just use my calculator, right? So 90 minus 45.6. Yeah, 44.4. So So angle P is 44.4, right? And then finally, we could find little I by Pythagorean's theorem, right? So I can go, okay, little I, I'll go I Pythagorean theorem, which is a 3,000-year-old math that we still use, but it's not a proof, right? I squared plus 7 squared equals 10 squared. What's 10 squared minus 10 squared minus 7 squared. So I'll take this I is equal to the square root of 51, or whatever that is, right? Square root 51, and I get about 7.14. Okay. So the big trick is if you need to find the angle, you just have to use the inverse button. It's pretty easy, isn't it? Okay, let's look at example 2. Am I going too fast? Yeah, I'll wait for you. So you're good, aren't you?
I'm great.
I had you for geometry.
Yep.
You know this. Trig's actually pretty easy, isn't it? Once you get the hang of it.
All right, we're good.
Okay, example 2. So example 2 is different because I know the acute angle, right? So that's what we did Thursday. So again, if you know the acute angle, we're going to use these steps, right? And I do know the acute angle. The acute angle is 72, right? So I like to circle it. Just gives me a visual. Let's use the given side. Okay. And then Natalie,
Yes.
either I'm going to find little a or side a. See, I'm doing this. Or I'm going to find little c. What do you want to find? Little a or little c? Side a or side c?
C.
C it is. Let's find side C. So from the angle, right from the angle, that's my opposite side, right? And that's my hypotenuse. So which one am I going to use? Opposite hypotenuse. Which one am I going to use? Okay. Sin's for church, but we'll try sine. Okay. We'll go sine of 72 degrees equals, and not theta, because theta is just a, the theta is just a symbol for your angle, right? That theta is just a symbol for your angle, so sine of 72 is equal to the 21, that's my opposite, over my little c, because that's my hypotenuse, right? So let's skip a step. We know that what Ann Lynn did on our warm-up, she brought up the, so if the variable's on the bottom, we wound up really just kind of switching places with these, right? And that would be a lot faster. We know we'd bring up the c, and we divide by that. So if we'll just bring them and go c is equal to 21 divided by the sine of 72. Does that make sense? It's just a shortcut, but we know we'd have to bring it up and then divide anyway, so let's just do that in one step. Use our calculator. Clear that. I'm just going to go 21 divided by the sine of 72, and I get an answer about 22.1, right? So little c is about 22.1 centimeters, because it's the side, right? Okay, circle that. How am I doing? Thumbs up? Does it seem pretty easy? Okay, then, what else do we have to find? We've got to find little a. So there's two ways to find little a. I could use cosine if I wanted to do trig again, or I could do Pythagorean's theorem, right? You guys probably like Pythagorean's theorem. I'm going to use cosine just because I think I'm a little Mr. Smarty Pants. Okay, so what if I go cosine of 72 equals little a. Oh, actually, I can use tangent. I'll do cosine. What the heck? Little a over my 22.1, right? Or Pythagorean's theorem, right? So if I multiply that up, I'll go 22.1 cosine of 72, and I get about 6.8. So I've got little a is about 6.8. And you could use Pythagorean's theorem. I just wanted to do trig again, okay? Angle A is easy. You guys agree? Am I going too fast? Okay. Okay.
Yes.
Angle A is easy. Angle A is just equal to 90 minus 72, which is 18 degrees. Okay, how's that? Now, trig is the most used math. Not arithmetic, but math. Next door, they've used a lot of trig to get angles and build things. Okay, they really do. So, example 3. A builder is constructing a wheelchair ramp. the height is 18 inches, and the ramp is 50 inches long, okay? What is the angle of elevation? So let's draw a ramp. 18 inches is the height of the ramp, and the length of the ramp is 50 inches long. Now, I had this happen to me once, a long time ago. I thought I'd built some stairs. I liked my stairs. I didn't know anything about code. They were pretty good stairs. They were. I thought they were great stairs. We went to sell the house, and the guy who was like the inspector said, you got to tear these stairs down and rebuild them. I go, what? They're beautiful stairs. They're not to code. All right, whatever. So if we got a wheelchair ramp, they have to be in code, right? And if they're too steep, then Granny can't get up there, right? So we got to find out what the angle is, and if our angle's not a good enough angle, we got to tear it out and rebuild it, right? Okay, so check it out. Do we know an angle? Do we know an angle? Do we know an angle? No. So we're going to have to use this, right? So we're going to use the opposite and the hypotenuse. You guys agree? From the angle, opposite side, hypotenuse. Sine or sin if we're in church, right? So we go sine of theta equals 18 over 50, right? How's that look, Bailey? All right, opposite over hypotenuse. Now we need to find the angle. So what button do we push? Angle, what button do we push? Second, right? The inverse button, second button, right? So I'm going to go sine inverse of 18 divided by 50. So, all right, I can do that. Sine inverse of 18 divided by 50. Okay, see that? Everybody see that? About 21.1 degrees. That is really steep. That really is. 21.1 degrees. That is a bad ramp, and they're going to have to rebuild that ramp. You agree? That's pretty darn steep for Granny to get up, right? So they're going to say, dude, go back and rebuild that ramp.
I built my ramps at like 85 degrees, so then they have to just like be really yoked if they want to get up my ramp.
Or have a good skateboard, right? Yeah.
They'd be able to rock climb up with their arms.
Yeah, I like it. Okay, turn the page. Okay. All right. So a submarine descends 30 feet vertically every 100 feet horizontally. So, all right, so here's my ocean water, my little ocean water, right? And my submarine is on its way down. Here's my little submarine.
What is that?
That's my submarine. Here's my submarine. Doesn't that look like a submarine?
Yeah.
Right.
Now I see it. I couldn't see it.
So it's going to descend 30 feet. For every feet it moves horizontally, it drops 30 feet. Does that make sense? Every 100 feet it goes out, it drops 30 feet, okay? We need the angle of depression, which is that angle there, right? And so opposite adjacent, you guys see it? Opposite over adjacent. Do you agree with that? Opposite over adjacent. So which one am I going to use? Nope. Not sine.
Oh.
Not cosine. There you go. Tangent of theta equals 30 over 100, right? Calculate, I got to do the tangent inverse, right? Second tangent. Tangent inverse of 30 over 100. And use our calculator. We're going to go second tan 30 divided by 100. And I get about 16.7 degrees, which is fairly steep, but you know, that happens with submarines. You just hang on. It's just diving down. 16.7 degrees. Okay. All right.
When is our test on this?
I don't know. Good question. Maybe Friday. Okay. Example 5. A triangle has side lengths of 8, 8, and 4. Let me draw a picture, okay?
Yeah. I saw that.
It was pretty bad.
It was like the whole movie.
Okay, so draw pictures. Stop talking about the movie. Okay, now, here's my triangle, okay? And then I'm going to label it. How about ABC? Me as well. ABC. I'm just going to label it. So I need to find all the angles. A couple of things I know. I know it's isosceles, so I know angle A and angle B are equal. Do you guys agree with that? So if I get A, I've got B. Everybody agree with that? I know it's isosceles, but I'm using right triangle trig. I don't have a right triangle. So let's make a right triangle, right? So I'm going to make a right triangle.
Just split it on the middle?
Yeah, why not? Because it is an isosceles triangle. I can do that. 90 there, right? That makes this side 2 and that side 2. So let's work with one of the two triangles. Let's work with, I don't know, let's work with that triangle, okay? Because they're both equal, right? They're congruent triangles. So let's find angle A first. Let's find angle A. Right, that's right. So angle A, I have my hypotenuse and its adjacent, right? So I pick angle A to work with. I have its hypotenuse and I have the adjacent, right? So I'm going to have to set it up. Cosine, right? So I'm going to set up cosine of angle A equals the 2 over 8, right? Cosine of A, cosine of my angle is equal to the opposite over the hypotenuse. And then to find the angle, I have to do the second, or cosine inverse of 2 over 8. And I'm just going to use my calculator to get my answer, right? So I'll go clear second cosine, 2 divided by 8. And I get about 75.5. So angle A is 75.5. And so is angle B. You guys agree? So is angle B. Because angle A and angle B have to be equal because it's an isosceles triangle. So angle B is also a 75.5 degrees. Okay. So I got A and I got B because they're equal. And then to find angle C, let's find half of angle C, right? Let's find half angle C and then we'll just double it, right? Or we can go from 180. Might even be easier to just go from 180. Let's go from 180. Let's get the whole thing. Come on, let's go back to geometry, right? Let's just go 180 minus my 75.5 plus my other 75.5, right? Let's go out 180. Let's just do some geometry, huh? Yeah, I agree with that. And I get about 29 degrees. So angle C is about 29 degrees. Okay. Homework is a sheet. I'll give it to you in just a second. I've got to stop play and I'll pass out to you.